This is Professor Mani Ramachandran, and I am a faculty at Amet University. I am from the Marine Engineering Department. I am also the Director of Placements. The topic that I am going to discuss today is about turbochargers, supercharging and turbochargers. So, let us get started with the topic. The course subject is as follows. In this course, we are going to get introduced to the basics of the turbocharging system, why these supercharging is required, and next we will go on to understanding what are the different types of scavenging mechanism. Once we deal with scavenging mechanism and understand that, then we will also go into what is a turbocharger, what is its construction, what are the faults that may happen, etc. So, in this session we will try to cover what is the need for this turbocharging system, and let us get started. The turbocharger as a concept was started way back in the year 1905 by a doctor called Dr. Bucci. Okay. So, he wanted to increase the power that is generated in a cylinder. Typically in an engine cylinder, the power that is generated is restricted by the dimensions of the cylinder and the P mean that the cylinder can develop. So, if I have to, the power basically is more or less proportional to the amount of fuel that you are burning. If I have to burn more fuel in the cylinder, then obviously I need to have enough air to consume and burn that fuel that I am supplying into the cylinder. That is a reason why a concept called turbocharger itself emerged. Okay. Let us move on to the next slide. The turbocharger consists of basically a mechanism by which you are able to increase the amount of the air that you are going to supply. So, how do you do that? You have many options really. So, you could have a electric blower which is powered by an external source, and it runs a blower, and the blower adds more of air to the engine as the engine takes air on the intake. That is one method. The other method could be, I can have the engine, and from the engine's crankshaft I can have a gearing system. The gearing system can run and then it will drive a blower, and I will be able to add more. That is another mechanism which is possible. The third mechanism, which probably is the most intelligent and efficient, is why not I use the gas which is coming out of my cylinder, which is going to get out of the cylinder and go into the exhaust gas as waste gas. So, what effectively is going to happen is, I am going to use the air, the exhaust gas which is coming out of the cylinder, and I am going to use a turbine which is a gas turbine. I will rotate that gas turbine, and when the gas turbine rotates, it has got a blower attached to it. So, basically I am not spending any energy to rotate that turbine, and the blower which is attached to the same shaft will then rotate. So, let us understand this a little better. The advantage of whatever I told you is that the turbocharger, when it is running, it will generate or help the engine by increasing the density of the air which is coming into the cylinder, and the power generated will be more. Initially, if there were no turbocharger, the green area is the power that is being generated by the cylinder. Now, if I use the turbocharger, then I am going to generate more power. This is the PV diagram. The y axis is the P and the x axis is the V. So, the area under the curve called the PV diagram is going to become large, which means that for the same dimensions of the engine, I am now able to burn more of the fuel with extra air that I am producing in the cylinder. So, the most important factor here is I will be able to increase the mean effective power. So, what is power? Power is equal to the P mean of the cylinder multiplied by the volume of the cylinder. The dimension is the same, but I am able to supply more air, and the RPM of the engine. So, let us look at it little further. We will now talk about two concepts related to the grouping of exhaust gases. I was telling you that we are going to use what is called as an exhaust gas turbocharger, which had a turbine, a gas turbine, which is going to be driven by the engine exhaust, and we had a blower. Now, let us look at first the exhaust side, and then we will next talk to what is called as the blower side. So, the exhaust side, when you have the exhaust coming out of the cylinder, you next need to make it in such a way that the exhaust goes as you desire and rotates the turbine wheel in such a manner that it is able to generate the amount of rotation which is required by the blower. Now, let us see, there are two mechanisms which are very popular, which is called as pulse and constant pressure. First, I will briefly talk about some of the general known facts about this pulse and constant pressure, general discussion. Then I will get deeply into what is pulse, what is the constant pressure system in detail. The old engines used to have what is called as a pulse system. A pulse system, I will go to the next page. A pulse turbocharging system is a system in which whatever you are seeing here are the individual units which are giving you exhaust gases. Okay. So, what happens is I collect all the gases and send it out into the turbocharger. So, the moment the cylinder exhausts, that exhaust kinetic energy of the gas is being taken all the way into the turbocharger turbine side, and it is able to rotate it. Now, let us look at it a little more deeply. So, pulse system of turbocharging is one where the exhaust gases which is coming out of the cylinder are grouped in such a way that you are completely utilizing what is called as the kinetic energy and the heat energy which is there in the exhaust gases when the exhaust valve opens. So, the beauty is the exhaust gases are completely driven to the turbine wheel, and they lose the energy enthalpy in the wheel, and the wheel rotates at a high speed. Now, key thing to mention about pulse system is there should not be any bends in the pipeline, or the pipeline should not be large. The pipeline should be as narrow as possible, and it should lead as smoothly as possible towards the turbocharger. The timing of the exhaust valve is also very important. Here is a very important measure here. What you are seeing here in the red is the word of caution. When I am sending out exhaust gases, please remember that I have connected many units and the gas is going to collectively towards the exhaust gas. Now, it can happen that when one of my units which is in that common pipe which is leading to the turbocharger, maybe one of the units is taking air in and the exhaust gas of another unit is coming out. So, here instead of the exhaust gases going out to the turbocharger, it may end up entering the other cylinder. So, that is a challenge which will be there in a pulse system. So, in a pulse system, grouping of the exhaust outlet pipes which lead to the turbocharger is very important. If you do not connect it properly, then you will have the exhaust from one unit entering the intake side of another unit and completely messing it up as a system. So, key points to understand in a pulse system is that you need to carefully group the units as they are taking exhaust towards the exhaust pipe. Next very important thing is the pipes have to be narrow, and they should be able to quickly transfer the energy through the pipe into the sink. So, typically if you look at it, then let us assume that you have a 12 cylinder unit. Then in the 12 cylinder unit you could have the first 6 units connected to one single pipe, and it will go to the turbocharger. Similarly, you could have the next 6 units connected to another pipe going to the turbocharger. The reason why the pulse system used to be very popular earlier is it had a very special advantage, because you are using the kinetic energy of the gas as it is moving through the cylinder. So, all the energy which is there in the exhaust gas gets immediately transferred, which means whenever my engine load increase is needed, the engine speed increases, my turbocharger automatically responds and increases the speed of the turbine, which means I will get more air. So, the beauty of the pulse system is it will always be responsive towards the engine performance. Okay, let us look at this energy or enthalpy energy of the exhaust gas which is coming out of the cylinder. This enthalpy of the exhaust gas which is coming out of the cylinder is to be managed properly. So, this exhaust pulse from each unit will be coming at a certain high pressure and it will be going into the turbocharger, it lose its value. The moment one unit's exhaust gas goes and hits the turbine, the next unit which is exhausting will take up again the exhaust pressure and pulse, and repeatedly you will have pressure going up in the exhaust pipe, coming down, going up, coming down, like this. So, the pulse system of turbocharging will have a if you look at it very carefully, a variation in the RPM depending on the number of units which are pulsing. So, you could have at some point of time the turbocharger moving at, let us say, 8350 RPM, and next moment it might be at 8000 RPM. So, on an average you can say that it is about 8200 RPM is an average, right. So, this is the key thing. So, the idea is there is no one single steady speed of the turbocharger as such. So, it will be kind of a average speed which is in between some of this range. Okay. Gentlemen, I am just going to recap the first type, which is the diagram number 2 which you are seeing in this picture is what we are seeing as exhaust grouping. Here what you are seeing is different units are exhausting, and those exhaust is neatly conveyed to, instead of 1, 2 turbochargers on the engine. Okay. So, there is a grouping of exhaust gases and the exhaust gases are being led to individual turbochargers. Now, there is another system of turbocharging which is very popular, and in fact the most modern one, which is called as the constant pressure turbocharging. Let me explain what I mean by constant pressure turbocharging. In a constant pressure turbocharging, what will happen is the exhaust gases, as we discussed earlier, will come out of the individual unit. When it comes out of the unit, it goes into a common manifold or a cylindrical pipe. So, all units will, with their energy, kinetic energy, discharge into this manifold. So, this manifold will have a certain pressure on it, and that pressure will then be conserved in that unit as a single pressure, and because the pressure from each unit is coming in and the cylinder can have only one single pressure, this steady pressure which is required is then fed to that unit. So, in a constant pressure turbocharging, the inlet to the cylinders may be 1, 2, 3, 4, whatever it is, but the outlet from the unit is just 1 or 2, which means you will have a very steady speed and RPM which is happening on the turbocharger. If I can recap, the previous one I mentioned in a pulse system of turbocharging, you had an RPM fluctuation because of the pulse system. Here you will find that the diagram number 1 which you are seeing is a constant pressure turbocharging, where the units are individually exhausting into this manifold, but the outlet is one pressure only. So, your turbocharger will run at a very steady RPM. Now, romba mosam pattano paraval. Okay. Start pannava. Okay. The constant pressure turbocharging system is a very beautiful system where the exhaust gas which is coming out of the cylinder is neatly retained in the exhaust manifold, and that exhaust manifold gives a single constant pressure, thereby the turbocharger will run at a very steady RPM. Now, this is nice when the engine is running at high speeds and high RPMs. Imagine a condition where the main engine is running at, let us say, maneuvering RPM. So, in maneuvering you will have, let us say, the engine could stop, it could start, it could run at dead slow, slow, fast, ahead, etc., etc. So, when you have an engine which is going to work at different RPM, by definition the amount of exhaust gas and the pressure at which the exhaust gas is coming into the manifold is going to be very low. Now, that low pressure of the exhaust gas is then being fed into what is called as the turbocharger. So, basically you have somebody as a broker in between the turbocharger, the units which are discharging, and there is a turbocharger which is consuming. This system where you have a broker in between and then there is a consumer has its own challenges. At low RPMs, what will happen is the turbocharger, because it is not exactly connected one to one with the units, will not respond to the demand of the engine when the RPM is low. So, what will happen is in such a situation, the amount of air that is needed will not be exactly mapping, that is in maneuvering conditions or changing load conditions. So, then what is the solution? The solution is On ships which are having constant pressure turbocharging, you will have by default a blower called scavenge air blower. Now, what is the purpose of the scavenge air blower? It will run continuously up to a certain RPM when the engine needs to develop a certain amount of air pressure. Typically, when the engine is running, let us say at 0.1, 0.2 bar, the amount of air which is needed for the cylinder is simply not enough. So, engine will be giving black smoke as exhaust gas. So, to avoid that, what we have is the blower, when it is at lower RPM below a certain pressure, it will run continuously. So, this typical blower is generally an electric blower which is running from the external power source. This blower will then assist and support the engine by supplying air to the unit, and thereby you will find that the turbocharger is having the unit is receiving enough air and there is good combustion in the unit, and thereby we can avoid the exhaust gases. So, this is for a main engine. Now, let us look at this turbocharging, constant pressure turbocharging, which has now been introduced into let us say the auxiliary engines. When you have an auxiliary engine, and earlier we used to have all auxiliary engines having pulse system. So, depending on the load and the variation of the load, the amount of air that is required is almost proportional to the load on the auxiliary engine. However, now the constant pressure system, when it was introduced, there was a challenge because the engine is not capable of dealing with the air as it is required at various loads. There was a challenge. Now, how do we deal with this, right? So, in an auxiliary engine, what happens is typically whenever there is a change of load, there is something called as jet assist air. Now, what is jet assist air? It is air which is being supplied from the starting air system and it is given to the scavenger side. So, what will happen is, in addition to the whatever air that the turbocharger is generating, it will also receive an extra air which will then be used to be supplied to the engine, and the scavenge manifold will receive that extra air and the engine will be able to support the fluctuation load when the load is going high and low, thereby the engine will continue to perform well when the load variation happens. Okay. Now, we have so far I spoke about everything related to the exhaust side. Now, on the other side of the turbocharger you have the blower. Now, let us look at the scavenging side. The purpose of a gas turbine is to generate power in the enough rotational energy so that the blower can run. That is the purpose of a turbine. Now let us look at how the engine is being supplied with air. So, let us look at three systems that are available. Typically, scavenging arrangements is generally looked at in three formats. One is called as reverse flow and the other one is called uniflow scavenging. Right. Before that, I would like to define to you what is scavenging. Scavenging by definition is a process by which you are exchanging the exhaust gases which are there in the cylinder, and you want to completely remove all the exhaust gases which are left in the cylinder from the previous stroke and recharge the cylinder with fresh air, which will then be compressed, and then the cycle of combustion will start. So, the idea is I need a fresh charge of air, and I have three ways of doing it as I have mentioned in the board. The first one is reverse flow scavenging. Here there are two subcategories and we will then discuss what is called as scavenging. So, reverse flow scavenging, traditionally engines such as MAN or Sulzer, they were using what is called as the reverse flow scavenging. It comes in two formats, what is called as the loop or cross flow. What exactly happens is the engine is provided with an engine uses what is called as an under piston which will act like a pump. Now, what exactly do I mean here? The idea is when the engine is running, so the unit which is having a piston going up and down, the underside of the piston will be used as a scavenge pump. So, in addition to the turbocharger working, you will also have what is called as a under piston which is acting like a compressor and then will provide the extra air. So, let us look at it little more in detail in the next slide. Okay. So, we will what you are seeing in the diagram is called cross flow scavenging. This typically was used by Sulzer and its engine. Let us try to understand what is cross flow scavenging. As I told you, scavenging is a process by which you are going to replace the exhaust gases which are there in the cylinder with a charge of fresh air. Now, in Sulzer engines, let us see how it used to happen. The Sulzer piston used to be a long piston, and it used to have ports on one side which is called exhaust ports, and then you had scavenge ports on the other side. Typically, the exhaust ports will be higher than the scavenge ports. So, what will happen is please remember that there is no exhaust valve in a Sulzer engine. The reason why they did this was they were using the same liner for removing the exhaust gases. The same liner could also be used to send in scavenge air. So, in a cross flow scavenging, you will have, when the piston is going from the TDC towards BDC during the expansion stroke, the exhaust gas ports will get opened when the piston is going down. So, you will have exhaust gases coming out of the cylinder. After the exhaust gases more or less been removed from the cylinder, next the scavenge ports will get exposed. So, when the scavenge ports get exposed, what happens is you will have fresh air coming in. So, typically what happens in a cylinder is called, you can put it in 3 phases, what is called as the parts of scavenging. So, the first part of scavenging is called the blow down phase. What do you mean by blow down phase? When the cylinder is in its expansion, the piston is in its expansion stroke, the exhaust gases, let us say at 5 or 6 bar, is suddenly opened to these exhaust ports. What will happen is the gas will suddenly find an escape route out of the cylinder. So, the pressure drops significantly. Now, it is intentionally designed in such a way that the exhaust gas, when it is removed from the cylinder, it drops well below what is called as the scavenge air pressure. Now, when the the exhaust port is removed, there is a kind of a partial vacuum which is formed in the cylinder, in the exhaust port. Now, as the piston is going down, you will find that the scavenge port also gets uncovered. So, what will happen? There is a rush of air from the scavenge port, and it will go towards the cylinder. So, now what is going to happen? There was initially exhaust gases. The exhaust gases had has been removed, and there is a pressure which is below the scavenge port. What will happen? Scavenge air will enter the cylinder and go up and come out of the port. This is fantastic, but however, there are some challenges. If you can see that the air, you are expecting the air to travel to every part, scrub all these parts, remove all the exhaust gases. This is not going to happen perfectly. What will happen is, what you are seeing is there are some areas in the cylinder where the flow of the gases may not be perfect. In these places, you will have some remnants of exhaust gases remaining. So, that is one disadvantage with cross flow scavenging, where significant amount of scavenging happens, but there will be traces of exhaust gases trapped in some corners of the cylinder which cannot be removed. So, that exhaust gas plus the fresh air which is coming into the cylinder will then become part of what is called as the compression cycle. So, there is some unwanted exhaust gas still remaining in the cycle. Now, let us move on to the next one. The next type of scavenging which was very popular in the older engines is called loop scavenging. What do you mean by loop scavenging? In old MAN engines, we had the exhaust port and the scavenge port in the liner in the same side of the liner. So, basically what I am trying to say is, you had a liner and you had exhaust ports, and just below that you also had scavenge ports. Now, let us look at the diagram. In the diagram, what you see is you have the piston which is going to do the power stroke. When the piston is doing the power stroke, when the piston is going down, first the exhaust ports get exposed. So, what will happen? The exhaust gas is going to rush out of this liner and go towards the exhaust. Now, as the piston moves further down, you will have scavenge air rushing in. So, what you are seeing is exhaust gases and scavenge air entry is on the same side. Please remember that the exhaust gases is at 400 odd degrees centigrade when it leaves. The scavenge air, when it enters, is at around 40-50 degrees centigrade. When you have on the same side two separate ports, you are now having what is called as the differential thermal expansion in the two areas of the liner, which is not necessarily a great thing. Now, like if you remember the previous concept called cross flow, in loop scavenging you expect that the exhaust gases have gone out, then you will have scavenge air coming in and the air is then circulating in the cylinder and then going out and pushing out the exhaust gas. If you see, you are expecting too much from the flow path of the gas. There will be pockets in the loop scavenging of the cylinder where remnants of old exhaust gases are still in the cylinder. Not the best of things. The next cycle, when it is doing the compression, you will still have exhaust gases, which is not necessarily great. So, this continued to happen, then the overall the industry realized that probably it is not the best of things to happen. B&W as an engine then decided that they must go in for some changes. So, they then decided that they will go in for uniflow scavenging, right. So, the B&W engines, B&W is a Danish engine which used to be very popular. The B&W engines traditionally when they were manufactured and designed, they had a very simple concept called, there used to be exhaust ports and there used to be also what is called as exhaust valves. So, the difference between the previous two models that I discussed, that is cross flow and loop scavenging, is you have the ports with respect to exhaust and you also have ports with respect to scavenge intake. Now, we are talking of an engine which has got exhaust ports, but you are having the exhaust the scavenge ports, but you are also having exhaust valve. So, the engine is very different in this case. You will find that there is an exhaust valve at the top of the cylinder. So, what is going to happen? You are going to run the engine. When the engine is running, when the engine is moving toward, piston is moving toward BDC, when the exhaust valve happens, the exhaust gases is going to come out of the cylinder and go out from the top. Now, the scavenge port which is at the bottom will then supply air. So, what is going to happen? The air is coming in, the air is swirling inside the cylinder, moving in, and then it pushes out most of the gases. Do not tell me that there are some small pockets here. Yes, there is nothing called as perfect scavenging, but near to perfect scavenging is what we are trying to achieve. A similar system which was done in an engine called Doxford. In this Doxford engine, we had two pistons instead of one. One was the piston which was operating the exhaust valve, and we had these scavenge ports in this engine. So, in an opposed piston engine, we had what is called as similar to uniflow scavenging. So, in the opposed piston engines, the exhaust ports were at the top and the scavenge ports were at the bottom. So, when the pistons were very close, there was combustion, and as the pistons went apart, the exhaust port used to release the exhaust gases and it used to go on top from the top. Now, as the piston went further, it would then open up the scavenge port. When it opens up the scavenge port, from the bottom the scavenge air is looping like this, and then it will kind of go out of the exhaust port. So, here we are achieving what is called as very good scavenging process. So, this is the beauty of the opposed piston engine and the uniflow scavenging system. So, let us move on to the next concept, right. So, let me talk a little bit more on what is called as the scavenging process. Let me repeat one more time. Scavenging is a process where you are going to remove the exhaust gases from the previous cycle and replace it with a charge of fresh air. Ideally, that fresh air should be 100% fresh air and not have any traces of the previous exhaust gases. While it might be true and required, that is not a perfect case. Let us look at this scavenging and break it down into parts. The first part is called as what is called as the blow down phase. In the blow down phase, if you remember, I discussed it briefly, that when the exhaust gas is at about 6 or 7 bar is available in the cylinder, the exhaust ports or exhaust valve opens. When that happens, the exhaust pressure drops significantly down and the cylinder pressure drops and the exhaust gas rushes into the exhaust manifold. Now, when the exhaust manifold has received enough air, the pressure is dropped down, then the scavenge air is allowed to enter in. That this phase where scavenge air is rushing into the cylinder and filling up the cylinder to the best extent possible is called as the proper scavenging phase. Now, there is one more phase to scavenging which is called as post scavenging phase. What do you mean by this? Post scavenging means after the the air has entered the cylinder and it is then what happens is the exhaust port or valve remains open and the scavenged air is still coming into the cylinder and it is blowing out of the exhaust port or valve. Why do we need this? It is more like a syringe. When you have a syringe and a doctor, what does the doctor do? When he has to inject the injection, he will first press the syringe like this. So, what happens because of this? The extra air or bubbles will come out and the syringe is then ready for the injection. So, same process. The idea is you have to make sure that you give enough time for the exhaust gas to be removed from the cylinder and you have more or less what is called as a charge of perfect air. Let us go on to the next topic. Now, I spoke so far about turbocharger. So, let me talk a little bit in detail about turbochargers. Turbocharger fundamentally is a single unit. Now, the unit does not need any extra power if you call it a turbocharger. So, what is happening? You have a turbine wheel which is on one side and on the same shaft you have what is called as a blower wheel. So, what is going to happen? The turbocharger is going to have the exhaust gas coming in, so there is a wheel and it has got turbine blades, and on the other side you have what is called as a blower, which is consisting of the blower. There is an inlet volute casing and then there is the air which is coming out of the inlet volute and it is coming under pressure and it is going into the manifold. Okay. So, because of this you will have the power increasing and the torque increasing the unit. Now, let us talk of another concept called turbocharger surging. What do you mean by turbocharger surging? Now, when the turbocharger is in operation, okay, so there is a constant flow on one side of exhaust gas going into the cylinder and the turbine wheel is rotating, and because of that the blower wheel is rotating. You have air from the atmosphere coming in, it gets compressed and then it goes into the cylinder, right. So far so good. Now, when there is a sudden variation of load, what happens? There is a turbine wheel which is let us say load increases, the amount of air which is needed is not enough. So, what will happen? The fuel burnt is more, but the amount of air inside the cylinder is less. So, sometimes what happens is the load increases, but the engine is unable to respond. So, what will happen? The air which is in the manifold then becomes a reverse flow and it goes and starts blocking the blower's turbine wheel, because the pressure in the scavenge manifold is higher than the pressure which is being generated by the blower. So, if that happens, because the turbine wheel is not rotating fast, you will have what is called as reverse flow. When there is a reverse flow of air, instead of the air going inside the manifold, the air goes back towards the blower side, then it will start braking it's like a car brake, when you brake, what happens? Your speed decreases. So, the blower wheel is going to get braked. When that braking action happens, what happens is there is a amount of resistance. So, that resistance that the blower is experiencing is called surging. The typical symptoms of surging is there is a huge moaning noise from the engine, woo, woo kind of a noise will happen. Now, surging is a indication that there is an improper demand supply on the blower side. The cause may be from the turbine side, but the effect is being felt by the blower side. Now, if the surging happens, you need to see it in the context of what is the condition of the engine and the sea conditions in which the engine is running. If there is a load variation because of rough sea, then any engine, whatever be however good the turbocharger be, there will be some bit of surging because of variation of load. However, if you have surging which is happening very, very frequently, it means one simple fact: your engine is somehow having some problem and we need to look at it from a perspective of what is wrong with my turbocharger. So, what is wrong with the turbocharger? The reasons for surging could be any number. Let us look at it. So, what are the causes of turbocharger surging? It could be a dirty filter, the air intake filter, it could be a dirty cooler, or it could be that the scavenge ports are choked, or it could be that the turbine side is dirty, there is a back pressure on the exhaust gases as it is going after the turbocharger, or there could be a sudden load variation on the engine, because of which the engine is unable to cope up, or it could also happen that the fuel injection system is having a problem, or it could happen that you have 2 or 3 turbochargers in the engine, one turbocharger is kind of having difficulty and there is a poor match between the air that is required by the engine and what is being supplied by the individual turbochargers. So, if there are multiple turbochargers on the engine and they have sudden snorting, which is called surging action, then you need to look at it from a different perspective. There could be something wrong with the fuel that you are supplying, or it could be that the exhaust gas passages are choked, or the exhaust turbine itself is choked. Okay. Right. Let us summarize what we discussed today. My intention was to introduce you to the topic what is called as the exhaust grouping. We are talking about the operation of an engine. So, we are looking at exhaust the engine as it's going to happen. So, what we discussed was we need to make sure that the exhaust gas as it is being supplied needs to be grouped and taken conveniently to the turbocharger. So, that is on the turbine side. So, how do we do it? There were 2 methods which we discussed. One was called pulse system and there was another system called constant pressure system. There are merits to pulse system. It is very responsive. You need to have small diameter pipes and it helps when there is load variation. On the other side, you had constant pressure system, which we discussed, and while it is good at steady load, it is not so comfortable when it is the engine is experiencing variation of load. Then once we discuss the topic, we then moved on to what is called as the scavenging process, which means from the exhaust side we went on to the blower side. We discussed what is the basics of scavenging. Then we looked at 3 different methods. Basically 2 of them are part of a similar concept. The reverse flow scavenging had 2 areas. One was called the cross flow scavenging and the other one was called reverse flow scavenging, right. Cross flow and reverse flow, you had the exhaust ports and scavenge ports which were being used for operating. So, inherently there was a difficulty. To overcome this difficulty, the uniflow scavenging proved to be a boon, because you are receiving scavenger from one side and then you are supplying exhaust taking out exhaust gas from one side. Uniflow scavenging is very popular and the most standard system which is used on large 2-stroke engine. Then I spoke about what is called as parts of the turbocharger briefly. There is a lot more to discuss about it in this class, and then we spoke about a concept called surging. So, the phenomena of surging, why it happens and what could be the causes were discussed. In the next session, we will talk some more about the construction of different parts, material used for turbocharger. Thank you, gentlemen. I hope to see you in the next class again.